Day 15 of 75 in our DSA and Go challenge. And today we're solving a problem that trips up every developer coming from Python or Java: sets. Imagine you're running a Go service that receives webhook events, and the same event ID shows up twice because the sender retried. You need to dedupe before writing to Postgres. In Python, you'd reach for a set. In Go, there's no set type. By the end of this video, you'll know the idiomatic trick, why it costs literally 0 bytes, and how to wire it into real backend code. First, the naive approach everyone tries. You keep a slice of scene IDs, and for every new event you scan the whole slice looking for a match. That's 4_id equals range scene. It works for 10 events. But this is O of n squared. At 10,000 events per second, your CPU is doing 100 million comparisons. Your dedupe step becomes the bottleneck. We need constant time membership checks, and that means a map. The question is, a map from what to what? Here's the move. You write scene equals make map string struct, not map string bool, map string struct, the empty struct. To add an ID, scene ID equals struct. To check membership, underscore OK equals scene ID. That OK is true if the key exists. That's your whole set. The common OK idiom is Go telling you, I only care whether this key is present, not what it maps to. No imported library, no set class, just a map and an empty value. Now why struct instead of bool? This is the part that makes your Go tighter everywhere. Run unsafe, size of struct, and you get 0 bytes. A bool is 1 byte. On a million item set, the bool version allocates 1,000,000 bytes of values you never read. The empty struct allocates nothing for the values. Go literally points every key at the same 0-width sentinel. It's not just a micro-optimization, it's documentation. Struct says to the next engineer, this is a set, the value is meaningless. Bool invites the question, what does false mean here? Let's make it reusable with Go 1.18 generics. Define type set, t-comparable map, t-struct, then methods, func, s-set, t, add vt, s, v equals struct, a has method returns the common OK check. Len just returns lens. Remove calls the built-in delete. Now you've got add, has, remove, len, a real set type, generic over any comparable key, strings, ints, whatever. And under the hood it's still that 0 overhead map. Set math without any helper library. Union, make a fresh set, range over both inputs, add every element. Intersection is the useful one for backends. Say you're checking permissions, 2 slices of roll strings, and you want only rolls in both. Loop the smaller set, and for each element check if underscore OK equals other roll. OK, then add it. 1 pass, early membership test. O of n. Difference is the same shape. Add from A only when the element is not in B. Notice there's no magic. You can read every line and see exactly what it costs. That transparency is the Go trait. Now let's ship the real thing. That webhook dedupe. Func dedupe, IDs, string. Inside, scene, equals make, map, string struct, len IDs. Notice I'm presizing the map with that capacity hint. Fewer rehashes, real speed up at scale. Then range the input. If underscore OK equals scene ID. OK, continue. Otherwise add it to scene and append to your output slice. 1 pass, O of n, and your output preserves first scene order, which a sorted approach would destroy. That ordering matters when your batch writer expects events in a rival sequence. So the interview takeaway, when someone asks, contains duplicate or dedupe this stream. The idiomatic Go answer is map, t, struct, O of n, 0 value overhead. And you can explain the struct versus bool trait out loud. That's the signal they're looking for. Day 15 done. The key takeaway, Go skips the set type on purpose, and map, t-struct, makes the 0 allocation intent explicit. Subscribe for day 16, where we tackle frequency maps and counting.